A very shrewd student, Kai Susin is here. She will show me some timing from the back. So don't worry about timing. We won't drag. Huh? It's being monitored. Now, see, the public thinks, when you say green, public thinks that it is rubbish, not throwing green energy, okay? But the industry sometimes, rightly or wrongly, at least in the past, we used to think that it's a waste, okay? Sometimes it's money thrown out, okay? Then we think that it is law, okay? So it's difficult always. This sort of image are there right now, okay? Of course, this is changing, but this still persists. So what we'll do is, we'll go and define. This is some of the more official ones. So if we look at it, so if someone is green, not green at all, sort of green and very green. So I wish we have a greenometer, but unfortunately we don't have this greenometer. So when you talk about green, the social people will look at it differently. Many people will look at it differently. So I would like to define a kind of a parameter here. So when you look at it as an engineering perspective, I know there are many non-engineering audiences around here, but today my focus area will be that, which is measurable greening. Therefore, we're looking at many things, but I'll be looking at what engineers' perspective is in terms of green, which I'll explain after this. Now, let's look at this. This is Malaysia's situation at least until 2013. See, the green one is what we talk about, what our Prime Minister has been talking about, carbon intensity. See, if you look at it there, we are currently at, in 2013, slightly higher now, probably about 260, 270. Industries produce 235 million tons of CO2. Okay, that's the red ones. If you look at the green one, so green one is basically, if you look at this, green one refers to this. So basically we are now 0.75 at 2013. Some time ago at 2005, we were a little bit here about 1 point something. It means that at 2005, for every dollar of GDP generated, USD dollar generated, we were producing something like 1 kilogram of CO2. Okay? So every USD, 1 kilogram of CO2. Now, right now, we are at 2013, slightly lower now. We're looking at 0.75. This was achieved not by reducing CO2, but increasing the activity. You see, this is measured as kiloton CO2 per USD. So we increase our activities. So when you decrease the denominator. So that achievement was done mainly because increased activity, oil and things like that. Okay, so are we doing well? At 0.75, are we doing well? That is the idea. So why this is important? Because 20 years ago, if we look at it, it was all quality. You see, ISO, people are talking about ISO. If you don't have ISO, you can't export your product. After that came a little bit of human rights. If you employed small kids and all that. All that has been slowly being taken care of because of the globalization and things like that. The next dimension is environment, I believe, soon is coming. So if you say in 5 years' time, economic sanctions imposed or some kind of trade barrier is imposed because of the environment, it is not surprising. It is already happening already. So it means environment means business. Now, let's look at this. This is, we could only find this data. This is million metric tons. So we were very low. Then suddenly we jump up. And 2013, we can see we jumped to 230 something. If you look at Japan. So in terms of total amount, we are low compared to Korea. They have a big activity total because bigger population, bigger activity, bigger economic activity. This is the metric tons. Now let's look at this. This is per capita. It means each one of us how much we are producing CO2. Now Malaysia is, we are looking at 7.7. Our standard has gone up. We become more consumer society. So each one of us are responsible for 7.7 tons. Probably it's about 8 8 something tons now. If you look at Japan, Japan is of course a little bit higher. Philippines, very low, probably because the activity is also low, the economic activity is low. You look at Thailand at that level, Singapore at this level, they have reduced tremendously here. Yeah? South Korea. So these are numbers that reflect the type of industries they have. The next one is more interesting. Okay, if you look at it here, Malaysia, as I told just now, 1 kilogram per USD. If you look at Japan, even though they produce a lot, theirs is only 0.264, very low. It indicates their industries are much energy efficient, probably. They produce very much less carbon intensity. If you look at Philippines, even though they produce a bit higher, but it's considered probably half of us. Thailand, this level. So Thai industries are a little bit more worse than us. Singapore, around us. Look at South Korea. Look at Indonesia, a little bit same with us. So what you can see is that, let's say, I want to look at our performance. It doesn't matter how much in total quantity we produce, but look at performance. If I just look at this one, Japan is doing very well. It means their industries are performing environmentally well. If I take this as an indication, probably they are more energy efficient, they produce less waste. These are the things. So if you stick to this as a criteria, which this has already been adopted, it doesn't matter how much quantity you take out, but it's the intensity that you produce. I mean, it shows your industry is doing how they are doing. Let's say, if I'm the global warming effect gone sour, gone bad, and if you want to use this as a trade barrier, it says that, look, you guys have to meet this level or that level. Is our industries prepared or not? You see now, there is two things happening to our industries. Number one, no one pays for polluting the environment. There is no carbon tax. Many countries has imposed carbon tax. It means there is in Europe, is there already, number one. There's one side. Another side, we also subsidize our fuel. So when you subsidize our fuel, we become cheaper. So one side, you don't punish people for polluting. Another side, you support people by giving in cheaper fuel. So therefore, there is no incentive for people to become more environmental friendly and achieve this sort of environmental performance. Now, we are okay now. But remember, we are a member of WTO. We are very much connected. We are very much export oriented, very much import oriented too. So if there is a big, you see now, the heat is there now, right? Heat is there now, very hot. This is partly because of the global warming as well, right? So if this continues, some time to come, it is not impossible for some sort of regulatory measurements put in forward. Example, I'm just saying example. Let's say Malaysia as a whole is given CO2 of 300 million tons in the year of 2020, cannot exceed that 300 million ton. Okay? It's up to the country to mitigate the 300 ton. Then your licensing to operate, licensing to manufacture will go back in hand with your carbon intensity. How much you can produce. So that is, in my opinion, will happen. Then, these things will come into play. The question to ask is that, is our industries ready? Especially the small and medium ones. Why? These are some of the development that we have gone through. Our environmental well-being in Malaysia started with the 1974 Quality Act. Then we became signatory. You see, Malaysia is very good at signing. We are signatory of, in terms of environment, we sign everything. Probably in terms of human rights, we have not signed a couple of items. But economy, environment, we have signed everything. In that sense, we are very much a good corporate country lah kata orang. We do very well. So we sign. We go for all the signing. We go for all conferences. We promise. Okay. We also sign sustainable development. So when you sign this, it means you agree to play the game that other countries play. So a lot of things need to be done. environmentally sound technology. There are a lot of regulation at the back. There is Agenda 21, many things, okay? Then in 2009, we didn't commit, but voluntarily commit for a reduction of 40%. There were some stories how we commit. It means intensity. So it means in 2005, we were producing about 1 kg of CO2 per USD. We say by 2020, we'll reduce that to 0.6. Have we achieved that? Almost there, but in a different strategy, not enough. Then in 2014, our Prime Minister declares 33. So from here, we have almost achieved 33%. Okay? By how? By increasing the economy. But the total quantity still remains. After this, we'll be stagnant. So our industries, in conclusion, we are not ready if environmental game comes in terms of carbon intensity. That's what we are trying to make a point. What is our current status? Now, so this is apparently, okay, anyway, these slides were prepared by one of my students, Raja. So this is apparently the modern way of putting in your data. So the first one is 4% from industrial processes, 90 are from land use, fossil fuel. Okay, here, this is non-fossil fuel industry. So this is also industries is included here, 87% from fossil fuel. Then out of that, 20% is industrial use of fuel. It means these fuel are used in the industry. And one more thing is 32% of the GDP are from SMEs, 65% job opportunities are from SMEs, and 99% of all business are SMEs in Malaysia. Numbers. And we have more than 600,000 SMEs. This is where I decided to work with SMEs. I have to welcome the unit industry Jao from DOE. The boss is here, Panurani. And we have worked together with them. So after this, I will share some of the activities that we have done. So this is the situation here. Now, then what is green as far as the industries is concerned? Strategies, environmental management system, policies, dedicated resources, and then we are talking about waste for industries. And they should be also talking about control technologies to become waste. And obviously now we started talking about carbon emission intensity sort of a thing. So now I preach carbon intensity to the industries. I give them as a measurable value. Maybe it is right or wrong, doesn't matter, but it is actually a measurable value for you to see your progress. Now, so let's assume that we have high carbon intensity. We have to go a long way before we come in par with Japan, in par with Australia. How are we going to do? Normally, if you ask people inside, this will be the solution. Huh? Obviously, this is not something which is very easy. That's why when we go and talk overall strategy, this will confuse them. So what we do is that, we don't go into that. That solution is too big an approach. So industries is not interested. Huh? Lack of initiative, they also lack of R&D, lack of investment, lack of agency. So when I started this greening initiative with help of Department of Environment, so these are the problems that we hear, okay? Now, problem will be problem, but we started looking into some of the strategies in our, what do you call it, when we are approached to the industries. And what we started is, we realized that the problems is the things don't come in a big way all the time. See, we have big issues here. Global warming, ozone depletion, deforestation, river pollution. Then there are big ideas, you know. Okay, if we want to manage this, we go biofuel, bioenergy, green technology, green engineering, all that. Therefore, obviously, you have big investment. So if this is the model that we are, because these are all big solutions, you know. So if this is what we are looking at, it doesn't work in the long term. Because businesses exist to be profitable in the first place. Businesses exist so that people can be employed. You are not there just to solve problems so that the world will not have global warming issues. No, if you're going to talk to the owners, probably if I talk to Paul Ellis, who is owner himself, doing great stuff, he won't agree. He's not going to invest millions just because there is a problem in global warming, right or not? So the approach should be different. So what we thought was, think small. So what we did is, there is an issue, there is idea, there is a small investment. Some issues, you don't need investment, you just need to realize, to put certain things in place, which I can show some of the examples. Like that. So when you have like this, and you have small solution like this, the overall solutions become a big solution. This is the approach that I personally have administered in many of the places that we went. Now, the focus for development for industries have changed. When you say development, I'm talking about in terms of greening development. This is another perspective. You see, in the past, raw material, energy, this is a every engineer should know, their product, their energy loss. So what we were looking at it is, we're looking at this. Our 1974 regulations are based on this. You do whatever you want. At the end of the day, when you dispose of your waste, you better make sure you treat it. So the focus was on treatment. Let me share one irony with you. See, palm oil industry produces pomade, which contains probably anything between 20,000 ppm to 80,000 ppm of oil. And there are a huge amount of work done in how to recover this so-called good stuff still in the palm oil effluent, right? Digesters are designed and all that. But we are missing one point. The point is, why in the first place, in your waste, there are so much of stuff thrown out? In the first place, your process should be, the engineer should develop a process which doesn't have this waste inside. So our focus is shifted. Our focus is basically looking at what we can do, something that we didn't do a good job in the first place, right or not? Palm oil industries, digesters, it's a big industries, but very less amount of effort is being put into to reduce that oil content in the palm oil in the first place. Shift thinking, right? So so that's why the focus was always here. So we are thinking, we are not looking at this. I don't care if palm oil industries, because they're making money anyway. So what I do is, I look at the effluent still contains some oil, let me digest it, recover some gas, and there I go. But is that the right strategy? I should be looking at it. So therefore, now we start looking at a little bit more differently. It is happening now. Yes, I still look at this one, but I also look at processes, new technology, new material. And not only that, I also start looking at things here. Example, cereal. You have cereal. Apparently, cereal has got a very high carbon footprint. But the high carbon footprint comes not from your processing, but comes from your planting. Okay, so now, example, your what do you call? Your beef. Beef actually generate a lot of carbon footprint, not in the processing side, but in growing it. And do you know that beef gets more subsidy than human being in Europe? I don't know, it's still true or not. They get more subsidy, otherwise they cannot come into the market. Huh? So that's the truth. That's what Dato is saying. Huh? See now, we look at this. Okay, so this has shifted. But this is also slightly outdated now. People are looking at overall. You see, I was told Japanese companies, they want the overall. It's not only what you do in the process, how you manage everything. So you are looking at supply chain. You're looking at the factory. You're looking at the transportation. So now, if I'm producing something, I want to know where my raw material is coming from. See, the overall. So it means now the boundary is no more here, but people want to know everything now. This is where the business is going in. Now, there is a new profession now we call corporate image consultant. Okay, I don't know. Okay, so what this corporate image consultant does? You go into the premise. Yeah, premise is nice, clean. You're doing very well. No smell. Regulation is nice. You've never gone into any difficulties with the people. But see, where's your raw materials are coming from? Okay, where you're buying from? Who is transporting? Is a thuggish company transporting your this one? Because then, whatever happened to any of this change is going to affect your business. Let's look at BP. So they have this big accident. They lost billions. Food companies, you make one mistake, you lose your businesses immediately. So that is the effect of networked and connected world. So now people are worried about everything. So Japanese companies, apparently they'll ask for your carbon footprint. Whom are you buying from? What is your quality? I mean, they have been doing that all the time for quality, but now they're looking at it from an environmental perspective. As things has changed. Look at example. iPhone. Now, your weight of your iPhone probably less than a kilo, but they produce 110 kilogram of CO2 throughout their life. So each iPhone produces 110. Now, Samsung, much more than that. How they have done that? If you, sorry for those who are, okay, maybe the price is a bit cheaper. I'm not selling iPhone here. Now, how they do it? You look at iPhone. Have you seen the boxes and all that? It's the easiest of the package, right? We never thought about it. You can assemble it quickly, plug and play, a lot of things. That's what they have gone. They've gone very big here because they realized very early that these are things that will be tools in the future for their businesses. Not only that, in terms of technology, they are same. So where you win the war? You win the war in other aspects, being environmental friendly and things like that. So it's 110. So every iPhone that you carry, you have already contributed 110 kilo. So if you change one more, it's more. Eh? Now, let's look into strategies. We are doing with the time okay. So now, this, I don't want to bore you with this. You see, the strategies for greening, I'm just looking at industries. The government, legislation, incentives are there, infra, capacity building, industry CMS. I'm connected here because all this must work in cohort, civil society. So these are actually things that we are looking at it. Academia, R&D, consultancy means expert services and things like that. Now, having said all that as a background, this is what I have done for greening. Yeah? So in one slide, I've compiled. Now, as a chemical engineer, very simple, no? Actually, chemical engineers have been contributing, all engineers. When you say, I've developed something efficient, it means you have already contributed to the environment. I've optimized things, it means you have already contributed to the environment. So the word optimization, efficient system, and all that you're already contributing to the environment. Next time, you should rebrand yourself, things like that. So Prof Saad there, he says that I have optimized, what do you call, you have solar, right? Solar power tracking system. He has contributed in a big way because when you're efficient, you waste less. You consume in a better way. So design modification. So I have done a little bit here. All my work I can relate it to green. I've done green fuel. I've done energy intensification using mixing. I've done advanced treatment where we have developed some catalysts to reduce the temperature, reduce the pressure of the operation. So output is, I have 100 over journals in that area, more than 90 over postdocs, 9 books, 2 chapters, 3 IPs, and more than 150 conferences, and not to mention many of the hundreds of road shows that we have done for the industries. My collaborators, Department of Environment, RMIT, University of Ottawa, Satake. So we are working with Satake now to develop very high energy intensive mixes for various applications. NCOM is my latest collaborator. We are working here also to develop some specific energy efficient processes. Okay, this is Sage Fuel. This is one of the success story where we started with the research using industrial waste, scheduled waste to produce refuse dry fuel. It is running in Malacca now, successfully, I believe. And they are expanding. In fact, the other partner supposed to be here today, but he is outside negotiating some related business. EMAS, of course, environmental training center by DOE. And we have also developed some products here, photocatalysts, modified catalysts, dope catalysts. Some of my students are here. Refuse dry fuels. And I have also capacity built. I can say that I have trained more than probably 200-300 the Department of Environment officers. These are those who implement laws and regulations. They are trained now in this area how to green the industries. We have trained the consultants to audit the industries for greening activities, about 100 of them, I believe, 100, about 100 of them. And we have developed some what you call competency-based tests for those who wants to become green auditors. So all this has been done. Of course, I've done some mentoring. We have trained some young people. These are some of the products that I've produced: membrane reactors, modular system, bubble imaging, microbial fuel cell. I'm working with two ways. One side is your biodegradable waste. Another one is non-degradable waste. You can actually produce, treat the waste at the same time, produce some energy. Ultrasonic reactors, membrane. So all these I can relate back to my either use of less energy or less material, which contribute to a greening effort. Protocols, okay, this is some of my important achievement. Right now we have standard green industry auditing process. We have green industry auditing reporting format. We have green industry option generation protocols. I have green industry option evaluation protocols developed. Estimation of carbon equivalent. You see, this is a simplified version for Department of Environment usage. And we have also developed some categories for green award industry, which is not very popular. Probably Paul Ellis can attend next time around. These are some of my cleaner production audits. This book is available under Department of Environment. Okay, this one, my colleague is here, Prof Nick is here. We developed together. She's one of those who wrote majority of this, but it is a group work. Do-it-yourself manual. We have guideline for batik industries. We have guideline for small, cleaner production tips. Okay, here we tell small and medium industries how you can become a little bit more greener. Inside we have few, about 90 or 100 strategies that you can do. We have developed some guideline for juice industries, for printing industries we have. And this is what the latest one. This is for the industry auditor. We have developed about 100 of them. It means now if the industry wants, there are available auditors from the industry. Okay? And not only that, in EIA now, you see, what if you want to do this, you have to put it inside regulations. In EIA now, there is some element, correct me if I'm wrong, there is an element of CP now. It means now, nowhere in the world, except in China, that you make it mandatory for people to go green right now. You have indirect. You must say that, okay, you must meet this regulation, the regulation and all that. But right now, indirectly, we have put in some clause in our environmental impact assessment where processes, the new processes, you need to tell what are your greening input you have inside there. That has been made mandatory. So indirectly, we have put in there. Okay, now I'll go into some of the case studies. Kaixing, how are we doing with time, okay? Okay. I will talk about some, about 20 places that I went. So I will talk just as an example, yeah? Now, this is one of our early, this is vermicelli, this is mihun. So they use a lot of water, okay? Now, this water is not only money. What happens, this water, when you go to river and all that, it pollutes, okay? So it creates other secondary problems. So when we went there, what happened was, these industries are 20, 30 years old industries. This Malaysia, 20, 30 years ago, we buy and use. Okay, we buy and use. We purchase technologies. Huh? So many of these now can be upgraded with a simple upgrading. But what they do, they use as usual. You see, steam is there, water is there. What happened is, you see, 20 years ago, if you buy rice, my mother used to pick up all the, you have all these stones and right? So this is what you see in many of the kampung places. They will put this rice and they'll pick up everything, right? Because 20 years ago, the rice processing industry were not there to pick up all this. Right now, you don't have to do that. So if your raw material for them is that now, they don't even have to wash 4 times, 5 times with a huge amount of water. Things has changed. But what they do is they do as usual. So this rethinking, paradigm shift is required. Okay, so when we ask them, why are you washing? What are you removing? How much dirt are you removing? What bacteria are you removing? Why you wash? Example, you buy fruits from the supermarket. Most likely you bring back home and wash it again, right? Probably once or twice. This is our mind. Our mind is wired like that. But some of these items are pre-processed already. You can eat as, even the cut fruits you go back and wash, right or not. But some of these things are already ready to eat. They'll put there ready to eat. But we don't trust this right now. Industry is the same. What happen in the house, that's what in the industry. So still happening. So small judgment. So what we do is reduce number and volume, and also automation. Okay, simple automation, as simple as closing your tap, because sometimes water is very cheap in Malaysia, so you forget to close your tap, but when you end up in your wastewater treatment, it loads you. Batik, okay, we work with batik. I think Prof Nick and all that. Prof Nick is if she's a mak batik, I'm also a small prince batik lah dekat sana. We work a lot with batik, we call it pembatik. See what happened, these people, many of them are rich, you know. If you look at their workshop, many of them are doing quite well. Of course, there are big ones. Very dirty. Yeah? When we went there and studied, it took us almost 10 years to break into their mind, to let them agree with what we are doing. So they look dirty, but they are very green. So when you calculate it in terms of carbon footprint, they are one of the greenest in the world. Because they use less energy and all that. The only problem is that they indiscriminately throw their wastewater. Betul lah, Puan? And they refuse to do treatment. So now what happened? We went in, we educated them. Now we have guideline. We tell them we have guideline, now you follow. I was told soon there will be a penguatkuasaan. It's on the pipeline. So slowly we have educated them. We have given them some knowledge, Prof Nick also, with various organizations. So just imagine if they become green, look green. We can position them in the world market, not only for clothing, for wall as an art, batik as an art. You know, batik as an art, you know, not for the wall. Apparently Europeans like it. Yeah? So this. Okay, this one, loss prevention through, okay, this is automotive part manufacturing, high energy consumption. You see, this is one company in Bangi. So what happened? They were losing money. Wow, 10 minutes. 10 minutes remaining. They were losing money. Main issue is they have big, four big compressors where these compressors, the pipe were leaking. You see, air is cheap, but compression power is not cheap. So by just doing small maintenance, we could actually save them more than 100,000 per month. Yeah? Palm oil industry. Okay, palm oil industry has been there for 50 years, not much. What the technology was 50 years ago, probably 100 years ago, or 60, 70 years ago, still there. But what we see now is high steam consumption. Now we have this, the sterilizer is now horizontal. Now there is a vertical and an incline sterilizers, which apparently can reduce a lot of steam consumption. This is not widespread, but it's coming up. This is greening practice. Okay. R&D, main issue, high energy. Okay, this one is cooking oil. So we have cooking oil. You see cooking oil, this is also sponsored by Jabatan Alam Sekitar, almost $1 million. This cooking oil company, they buy oil palm. When you buy oil palm the day before, oil palm need to be kept at a certain temperature. If not, it will freeze. So keeping that temperature, it requires a lot of energy. So that's why high energy consumption. Practice just in time. You buy just in time. So this, no technology, but with this, you reduce a lot of energy consumption and also knowledge base. You see, after they produce this oil, they cure it in a cold room at 15 degrees C. But when we studied, this 15 degrees C is not required. You can actually cure it in a normal room temperature, but longer time. But anyway, after they make their oil, they'll take 30 days before they send overseas. So they have the time. So why we want to put it in the cold room and cool it and spend a lot of energy while you can put it outside there. So these are the strategies. Printing industry, PNB. Printing PNB is Berhad, Pencetakan Nasional Berhad. Okay, Pencetakan Nasional Berhad, they have high waste due to paper. People order different sizes, they have high, because this paper, 1 kilogram of paper equivalent to 4 kilogram of CO2. Now, by educating the client, you see, most of the clients are government clients, they don't care about environment. So we tell them, look, if you buy A4, you'll waste only 2%. If you buy A3, you'll waste only 1%. But if you go any other shape, you're going to waste a lot more. Do you want to go for A3, A4? So that sort of education is required. Okay, this is one of the classic one also. This is, okay, plastic resin industry. There's a lot of industries like this in Balakong. What they do is that the Maggi mee that you use now, the pack, the yellow pack, this is a very high quality plastic we throw away. They collect. And they produce very high quality resin for Hong Kong market. Why the Hong Kong buy? Because it is a green product. Because the carbon footprint is lower by 150% compared to the virgin material. They make a lot of money out of this. So here, wastewater we recycle at the permits. So we went there small, but you see, they are keeping it very dirty. Because of this, all these leaches go into their treatment. If they can do a little bit of more cleaning, which they have done it in their new plant, you have it there already. So simple processes. One more thing, productivity. Now, productivity is the biggest environmental input. Let's say 8 people can do a job in 4 hours. If they do it in 8 hours, your environment is gone, because for 8 hours, for the 4 hours extra, you have to go give them more electricity, more water, and things like that. Okay? Now, this chicken, they slaughter probably 20,000 chicken every minute, every hour. Now, if 0.1 second is delayed for every slaughtering, you're talking about 2,000 seconds, am I right? 20 times 0.1 is 2,000 seconds. 2,000 seconds is how many minutes? Few minutes, right? Now that will delay the process. When you delay the process, the whole plant is chill as 12 degrees C. When your process is delayed, you take longer time. And you have more energy consumption and also quality. So now, increasing productivity of workers. Pace, especially in fast-moving industries. Time and motion studies. If you drive, this side is the accident. Why this side is the jam? Because people look at it one time and they will automatically slow down, and jam is on the opposite side. Time and motion. Same thing in the industries. We look at shelf life. This is also one thing. See, we have a lot of, 5 more minutes, I'll request a little bit more. We have a lot of issues here. Now, when we started our industry, we are highly standard operating procedures followers. We are asked to follow some standards so that product coming from third world country goes outside, the quality is assured. We follow in a big way. Right now, 2 things has happened. We have become much more skilled workers. We have a lot of control of what we do with our process. So we could actually afford to operate on the go. We don't need 20%, 30% safety margin. Some of the Japanese companies, they don't even rework. They don't reuse things that has been spoiled a little bit where you can actually bring back. No, because you're worried that your product will be contaminated. You're worried for quality because your workers are not able to manage these things. Now, this has to change. Some products, the shelf life is 3 years. When you have a shelf life for 3 years, you have to put in more energy, more material inside, right? You have to have special bottles. Look at Levita, special bottle. But if your product is selling within 6 months, why you need 3-year punya shelf life? So let's look at it. Because the more shelf life, the more energy you put in. So do we need a very long shelf life if the product is running within 3 months? Do you need to buy chicken 1 year before your Chinese New Year or your Hari Raya Haji and keep in the fridge? What for? I can buy immediately and slaughter, use it, right or not? Because if you buy 1 year ago and keep it, you're going to use a lot of energy and the quality is going to go down as well. This sort of thinking. Huh? Sugar refinery, they have big motors, but any one of these doesn't have inverters. So with the inverters, electrical engineer tell you, you can actually save a lot of energy. We have gone into chemical industry. These are very unique ones. They produce, they react calcium carbonate with nitric acid to produce calcium nitrate, okay, for many things. But what happened now, because of the mixer design is not proper, 20% of your calcium carbonate doesn't get reacted. And this is defined as waste. And they spend almost 50,000-60,000 a month just to dispose of this waste. It could be solved with a simple design of these mixers, which we adapted as an undergraduate project, and it's quite successful. We have coconut paste industries, where, here the problem was they produce paste, about 30%, 40% comes back. It means they oversupply. So when you come back, paste, this becomes waste. And every kilogram of solid waste is producing 4 kilograms of CO2 in that sense. So what they do, simple logistics, management will reduce. Cane drinks industry as well, critical parameters. Okay, here we went, I think it is Kenju. See what happened in this place, they pack for people. So when people send in their product, if they are delayed in their process, they have to dispose of this product. What they do, they dispose of directly to wastewater treatment plant. So what happened, these bugs are like a human being, in the wastewater treatment plant. Human being, if you eat 3 plates in a day, it's okay. But if you are asked to eat 3 plates within 1 minute, we can choke. Same thing, microbes. So when you give microbe immediately, this high load of organic, they don't operate. So what we do is that we instituted a small dosage system, simple modification to the wastewater treatment plant. This problem was somehow solved. Semiconductor industries, MIMOS, they have very huge amount of electricity consumption. Why? Because they are processed, they go for very high level of particulate matter, which is not required. They design for very high level, but in operation they don't require. So by going in a little bit lower standard, which meets their operation, they could save a lot. Yeah? Because you pay for high standards. Huh? Same thing, electroplating industries. You see, electroplating, they wash. Okay? They use a lot of acid, but they use all information. You could actually, there are a lot of mixtures that you can work together to produce for you a good cleaning services. Packed food industry, same again. Wet market, yeah, wet market, there's a small project with the wet market where high amount of organic waste and leachate generation. This is again, I think this is one of the success where we have Agenda 21 program where people, we can look at vermicomposting. Dr. Zalina here, she's very good at that. Zalina, how are you guys? So yeah, no Zalina. Huh? Even hotels we have gone. Now if you go to a hotel, you can see those things that you want your towel to be washed again and things like that. So this is also greening. Okay, this is also another very interesting project we have done. So there was a company in Johor. You see the whole of Johor alone, Johor Bahru alone, they consume up to about 10 to 20 tons of chili paste a day. Yeah? So now they produce about 10 tons. So when they went there, they were returning about 2-3 tons daily. So when they bring back, they put inside the river in the kampong. Of course, there was a complaint from the kampong because the river became red. So when he went in there, it's a simple process. You know what they do when they send to supermarket? They send today, tomorrow they send again. The tomorrow's product is going front, right? What people will buy? If you go to market, if you look at the product yesterday's and today's, which one you'll buy? Obviously, you buy today's one, right? Yesterday's one get left behind, you return back. So small. Management at the supermarket is required. So what I want to demonstrate here, many of these problems, if you look at it, can be solved with simple solutions, no need investment. You look at this, bottle drink industries, it is another issue. Material lead to changeover. So it's a company, they produce a lot of product. They change over. When you change over, you wash a lot. You throw out. So by managing your production, you can actually reduce a lot of waste. Okay, I'll rush through because sign just came that I've finished my 40 minutes. Okay, so these are some of the strategies that you use. Target to operate closer at atmospheric, use of catalyst example. Equipment design, optimize and control process parameters, speed, flow rate, etc. For example, we have a lot of mixers. Mixers are the highest number in any industries. Now, these are not optimized. You run at 1,500, 1,300. A lot of energy is wasted. At one time, we estimated that it could be run into billion. That energy used to have this excess. So all this optimization process, increased productivity, seamless handling of goods, serious look into optimizing logistics, transport, as I shown, some of these things. Symptoms, attempt to source of problem and not just treat the symptoms. As you know, there's one story I read, I think, where this statue made from brass was rotting. So they call in a consultant. The consultant say the solution is to off the light on top of this statue early. So this person was very surprised. What has got light to do with this statue? Then he says that on top of the statue there is light. Light attracts insect. Insect attracts birds. Birds put their droppings on top of the statue. You need the cleaning chemicals to wash the droppings. And that cleaning chemical is the one that making the statue to go bad, right? So by offing the light, no insect, no birds, no dropping, no cleaning. So if you go to the source, the solution probably looks very simple, right, Shiva? So that's what we are saying, symptoms, new thinking, reassess your old thinking, and things like that. Now, there are myths and facts. I'm finishing, no worries. Greening is non-technology based, even though academy would like to work on the technology. But if you want to contribute to this so-called manufacturing industries, you got to think this. Not necessarily, this is an expensive activity, not necessarily. 30-40 options can be done without investment. This we have to believe. This is what we preach. Greening is only for the big boys, big MNCs, not true. Because we have the contribution from SMEs, large as well. All premises can engage themselves into greening activities. Greening is only for meeting regulations, wrong concept. This is for the long-term survival of the business. Okay. Now, number one, greening covers only pollution. Not true, as you can see. You can look at a very nicely looking, very beautiful plant, but they could be wacking up energy in a big way. Okay. On the other hand, you could be seeing a very dirty and smelly plant. Probably they're doing very well for the environment as well. Okay. Greening is only for promotional purpose. May have been true in the past, not anymore. Definitely not true in the near future. Greening is a non-profitable. Very soon, greening will be mandatory for all businesses. Now, greening, yes, it is not profitable now, but soon, I believe, when you have this carbon tax, when slowly our incentives, our subsidies are removed, we look at it more. Now, R&D for the future. I wanted to do this a little bit long, but I just have few information here. Water already more expensive than oil in many places, right? If you buy oil, in some places, it can cost you 7-8 ringgit. Of course, there are 30 cents, 50 cents, but these are low-level ones. In 2050, it is estimated that it is possible the global pricing for a barrel of water will be established. Now we only buy barrel oil. 2050, there will be a barrel of water, estimated. Water will be the source of many wars. We fought for land first, then we fought for oil, then we fought for influence. A long time ago, we fought for women, right? That's a long time ago. Now the next war will be fought for water. It is already happening in some part of India, Pakistan, Bangladesh. Pakistan and India. This will happen. So treatment, recycling technologies, waterless technology. ICAME, I know they have promoted waterless technology, waterless cleaning, where we don't use water for cleaning. Do you know you can clean by air? Let's say you have a rod. You can either use soap and water, or you can use air to clean it. You can use, okay? Affordable desalination, because we have a lot of water in the sea. But desalination is expensive. So how we can look at desalination processes, these are areas. Water reuse, recovery of hidden water resources. You see, apparently in the air there is water, we can get water. Our combustion process produce water, which we never think about recovering. We can start thinking about it, because in your car you produce water all the time, right? Okay. Of course, this is depletion, development of processes, harness solar energy, carbon capture technology, CO2 as raw material, advanced biofuels, and many more. Hydrogen production, water splitting, okay? Waste resources. There are a lot of work here, but we have to do more. So these are some of the areas that we can go into. Manufacturing processes, energy-intensive processes, low-carbon technologies. Green chemicals. Green chemicals is another interesting one. Bacteria-based catalysts, mimic the nature, photosynthesis, natural product-based chemicals, and productivity. In Malaysia, probably output productivity as number one. Yeah? Productivity, okay? Now, we have come to the acknowledgement. I would like to acknowledge my colleague from engineering, Madin, he's here, ever supportive of this. And I also like to thank Prof. Ramesh. Actually, this slot belongs to him. He graciously has given me this slot, because to get a slot for inaugural lecture is very difficult now. The next one, probably in September or something, next year, because there's only one professor a month, so I'm very fortunate. Unit Perundangan Universiti Malaya, Mas Nolita, are you here? Thank you very much. They have been supporting these activities a lot. University of Malaya as a whole, Chemical Engineering Department, Department of Environment Malaysia, my postgraduate students, especially Raja, Kaishing, and Razwana, who have been with me long time in this cleaner production. Not forgetting my friend here, Dr. Sumiani, and my dear wife here, Ramiza. And with this word, I would end it. In the quest for success, no opportunity is too small. So this goes for industries as well. Think small, the small will contribute to big. In Malay, there is a saying, sikit-sikit, lama-lama jadi bukit. That translates into something like, you do small, one day it will become like a mountain. So in effort, it is also like that. And thank you very much.
Thank you, Prof. Aziz. Now I would like to call upon Professor Dr. Noor Azwan to conclude the lecture.
Thank you very much, Prof. Aziz, for the very, very interesting lecture. Today, the first thing that I'm going to meet my wife after this, I'm going to tell her, do not wash the rice. Because you try to kill whatever bacteria is inside that rice. Anyway, it's a very, very insightful. As a close friend and a colleague, Prof. Aziz is a very, very good example of a man who can take care of both his career and also his family. His CV is a balance. He has impressive record of research, and he is one of the well-loved academics, not only in the faculties and also in the university. He has proven the academic can help in capacity building to contribute to the development of the country. His topic on greening Malaysian industry today perfectly reflects that. Sometimes we do not need technical solutions or multi-million investment to solve the problems that we have. We just need a change of attitude. His lecture today has taught us that we can definitely help transform the society if every one of us does his or her part. I'm also delighted to see that Prof. Aziz has produced so many publications and that the industry needs in order to be cleaner and better. What is more important, he has a big, big heart. Yeah? I don't know, maybe his wife knows better than me. I can see that he is willing to share his idea and has helped develop younger generation to continue his work. I believe that everyone here has benefited from his lecture today. Together, we can make the earth a better place for everyone, inshallah. Thank you very much. Let's thank him by giving him a big round of applause. Prof. Aziz Abdul Rahman. With that, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Dr. Nur Azwan. And I know the lecture has come to an end, but before I end the lecture, we have a little surprise for Professor Dr. Abdul Aziz. And it will just take a couple of minutes. I hope you can bear with me. And let me begin with a small story. You know, I work closely with Professor Dr. Abdul Aziz, and there was this one fine day not long ago. He came to my desk with a script of acknowledgement. And he told me, "Look, Kai-Shing, I want to thank this special lady in my life, and I do not want to thank her in any other paragraphs in which I thank the others. Can you come up with some nice sentence? Because without her, I wouldn't be what I am today." You know, at that moment, I was touched. You know, Prof. Aziz always appears strong as he is, and it is our honor to have her with us today. Let's put our hands together to welcome Puan Ramiza to the front, and Prof. Aziz. So as a support, Puan Ramiza has a small gift for him. Prof, would you like to say a word?
Thank you, everyone. I think I have to thank my wife for whatever that we have achieved. My kids are here. Some of my friends are here. I'm lost for words. Thank you very much, everyone, for giving me this opportunity. I certainly enjoy this. There is some lunch after this, right?
Thank you. Once again, I would like to take this chance to thank Professor Dr. Azwan for chairing the session, to all our distinguished guests, the faculty's management, and the ICR. Thank you very much. And as a simple appreciation, we have prepared a small lunch for you, a simple one, and it will be served at the conference room. But for the postgraduates, your lunch will be served at the Department of Chemical Engineering. Please proceed to the department. For the other guests, the lunch will be served at the conference room just outside this hall. Please follow our ushers. Thank you very much. Have a pleasant afternoon.